I want to talk about some of the main connections that Pascal's triangle has to uh, mathematics, the real world, a lot of different things. I was just using it the other day um, with Venn diagrams, believe it or not. So how do we come up with the Pascal's triangle? Well, we'll start with the 1. 1's the most basic number in the universe, right? And from that 1, we'll come up with, it'll duplicate. We'll make another 1. Now, I have those two 1's that I made through whatever process, and when you add them together, you get a 2, right? And then just to balance it out, I'm going to put my 1's back on the outside. Then I'm going to add these two guys together. I'm going to get a 3. Add them together again, I get a 3. Keep my 1's on the outside. Got to make a balance here. 3 and 3 together make a 6. 3 plus 1 is 4. 3 plus 1 is 4. And 1's on the outside. This triangle to me is all about balance. 4 and 6, 10. Another 10. 4 and 1, 5. 5 on this side. And 1's on the outside. Okay, and I'm just going to stop there. The triangle goes on forever. And that's kind of interesting. Okay, it's neat. But why is it important? So I'm going to hopefully connect a couple applications here that we've been doing in the past couple videos. I suggest you watch them if you're confused at all. So this triangle here is the same thing, except it's made using combinations. And basically what it means is on the top right here it says 0 choose 0. It could be written like this: Z0 C0, which just kind of stands for choose. It stands for combination, but I call it choose. How many ways, if you have 0 items, can you choose 0? There's only one way to choose 0, right? How about if I have 1 item? How many ways can I choose 0? Well, I can only choose 0 one way. Now, if I have 2 items, how many ways can I choose none of those items? This is one way. I just choose none. And no matter how many items I have, there's only one way to choose none of them, right? And likewise, if I have 1 item and I want to choose that 1 item, there's only one way I can do that. If I have 2 items right there and I want to pick both of them, there's only one way I can pick both of them. It's just picking up both of them. If I have 3, I have to pick all 3. And it's the same thing on this side. No matter how many items I have, if I want to choose all of them, there's only one way to do that. And what happens down the middle? Well, if I have 2 items, how many ways can I choose 1? Well, there are 2 ways to do that. If I have 3 items, how many ways can I choose 1? 3. 4 items, how many ways can I choose any one of those? There's 4 different ones I can choose from, and likewise down the triangle like that. Now, what's this 3 choose 2? Well, here's where the fun and the balance comes in. If I have A, B, and C, right, there's 3 ways I can choose A, B, or C. I could choose A, I could choose B, or I could choose C. Well, again, what if I have A, B, and C, but now I want to choose 2 of them? I could choose A, B, I could choose A, C, or I could choose B, C. Now, how is that related to the one above it? Well, choosing AB is another way of saying not choosing C. And choosing AC is like not choosing B. And choosing BC is like not choosing A. So how many ways can I not choose an item? Well, it's the same way as how many ways I can choose one item. So that's why 3 choose 2 is the same thing as 3 choose 1. And so what you're going to get is this nice little balance in the triangle, right? And the rest of the triangle is constructed the same way, just like Pascal's triangle. If you work these out or write out all the possible combinations, you'll find out it goes exactly like the triangle says it would. Okay, so that's very useful in dealing with combinations if you don't know the combination formula, right? Pretty cool. The next thing that it's very useful for is the binomial expansion. And if you're in algebra, this is clearly very useful. So x plus y, it doesn't matter what the x is, it doesn't matter what the y is, it could be variables, they could be constants, it makes no difference. If I raise it to the 0 power, it's going to always be 1. If I raise that whole thing to the first power, well, it's just what it is right there. If I raise it to the second, you'll know that one. The third, the fourth, and so on and so on. So let's explore that. What's x plus y to the 5th? This would be a nice, easy way of figuring this out. Well, according to Pascal's triangle, it should be 5 choose 0. I'll write these all out. 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. And then if I fill in my x's and y's, let me do that quick because I'm running out of time. Okay, I would get something like this. And notice that down the side of the triangle, my x's are increasing by a power. X to the first, second, third, fourth, and likewise with the y's. And notice over here, my x, it goes x to the 5th, 4th, 3rd, 2nd, and then over here it's y to the 5th, 4th, 3rd, 2nd. So I hope this is useful and an interesting tool on how to find binomial expansion and many